Hey guys, so today we're going to be taking apart something a little bit fun. Recognize this is an NES controller. It's one of these joysticks. Now it doesn't work with the non-flying games for some reason. I have another one and they both appear to do the same thing. On Super Mario Bros. Duck Hunt, pressing this button will switch you to Duck Hunt, and nothing else does anything, so I assume that's flying game standard. So... and I don't think it's broken. I think it's just not compatible with the non-flying games. So let's take it apart and see what happens. I really love like old stuff with Phillips head screws. New stuff's a pain to take apart. Old stuff is so easy. So if rumors are true, inside these things is sort of like a reverse shift register. $6.95, maybe not, don't quote me on that. But basically, to explain the operation, a reverse shift register just basically is what its name implies. It does the reverse. So whilst a shift register takes a serial input and gives you a parallel output, these take a parallel input and give you a serial output. So it can be used to, monitor many buttons at one time or something like that, which is exactly what Nintendo used it to do. The screw is being stubborn. So, if that is indeed the case, we should actually be able to interface to this thing via an Arduino really easily. So this is it. Really nothing special. We have some, little flimsy wires here and a really old school PCB with some, oh my god, cheap buttons falling all over the place. But with these cheap little onboard buttons. Oh, you gotta love that hand-routed PCB. Hand done, you can tell because it's all curvy. And by hand done, I don't mean they used a computer. I mean they drew it by hand. They may have used a computer, but it's been completely drawn by hand. And all the buttons are these cheap little, just basically metal things. And it's one-sided, really. It's not made by Nintendo, it's made by Craft Systems, but it's, it should be a little bit interesting. They've got, I guess this hole's to provide strain relief for the wires or something, but they've got a bunch of through-hole resistors, 47 by the looks of it, 47K, I believe. So, and then they have the chip, which part number appears to be rubbed off, actually. Oh, that's rather disappointing. It's made by Motorola. It appears they've scratched the part number off. How lame. Yeah, well, it is made by Motorola. It appears they have just one pull-up or pull-down resistor for each. So, yeah, that's really disappointing. Maybe I'll take apart another one to see if we can actually see what chip that is. Okay, so I've got another one here. It looks like this. And, well, I've unscrewed it, and, oh, that's a bit more fancy. Ah. See if we can pop this sucker out. And see what's... oh yeah. Look at that. That's much nicer. I mean, this one felt much nicer, but geez, it looks 10 times better on the inside. We have computer routed PCB. Nice buttons. It appears like when you press down on this spring here, it looks like what happens is when you move the joystick, it moves these little black arms here. It appears to actuate a little button. See if you can see the mechanism. You can see when I push down the spring, that little lever goes down. So, and they have that for all of them. So, but this one's the easiest for you to see. Switch here for the turbo, no surprises, done by a regular switch, regular old switch. And these buttons up top here seem to be done on a separate PCB that I won't take off. What I don't like though is, no strain relief on the wire connectors here. They have a really weird toothed thing. It's like there's free space between each of these wire connectors. But I guess that worked out for them just fine. So, on this one we can actually see the part number is an HCF 4021BE, and that is the only part in here. There is some transistor stuff that's all bent over. I guess we can see what the transistors are as well, if they are interesting at all. Okay, so these transistors are 59014s. Okay, so I assume, since that's next to the turbo switch, that those transistors, resistors, and capacitors are just form a small oscillator, slow oscillator, because this capacitor is 10 microfarads, but for the turbo. So if we follow, it seems like the outputs from this, I'm not sure of the schematic from this chip anyways, but all of these output wires here are taken from this chip here. So, maybe just me looking at it, but it appears to me as if some of these ones coming out here appear that a few are for power, and then the rest are just for just snake over through these resistors to this chip. So it appears that it's not the reverse shift register thing I was talking about. But still interesting. I will have to look up on the computer actually what a HCF 4021BE chip is. But that's the only chip on here. So, okay, so it appears that the 4021 is the sort of reverse shift register thing I was talking about. So I'll just get into a little detail about how this thing sort of works. Basically, it takes all the buttons, you have the 4 joystick buttons plus the 2 dot buttons, that's 6, and then start and select, so that's 8, so that this thing has 8 parallel inputs. So what it's basically going to do is when you have this parallel serial control or latch control, whatever you want to call it, it's called both things. When you have that high, I believe, it's going to update itself on the newest button presses, so whether they're high or low, again, don't know whether these buttons are active high or active low, it doesn't really matter. Easy enough to figure out. And then when you basically turn this parallel serial control thing low, it's basically telling the microcontroller processor, you're probably using a microcontroller, but the NES was using a processor. So it's going to tell the processor that basically, well, the processor is going to put the parallel serial control low. It's going to tell this chip, all right, now send me the data. So each time you pulse the clock pin, what it's going to do is it's going to send you the state of the next button. So what we're going to have to do to figure out which button is which is that rather than just, tracing out the connections on the PCB, which would not be the exciting way, is just connect it up to a serial monitor and just press the button, and if it's the third one, we'll know this is the third button. If this is the fifth one, we'll know this is the fifth one. If left, you know, like that. So we're going to have to do that. And I did actually find the pinout for this connector using continuity tests to these, and then since I know the pinout of the chip using continuity tests from this then to the chip to figure out what each pin was. So for anybody interested, and during this video, yes, I will actually use this controller to do something. I will get it working, essentially. But this is it. So this, where'd it go? Okay, so I have it arranged like that for anybody interested. Old school NES hacking. So with the slant on the left. This top left one is ground. The next one is clock. Then you have parallel serial controller latch, shift in, and then you have your positive supply VDD, and then these two bottom pins, as far as I can tell, aren't connected to anything because there's only 5 wires. If you look, there's only 5 wires coming in, so you know, they're not connected. Now the problems I had when using this are multimeter probes. Don't know if you can see this. Don't actually fit inside. So what I did is I had some power resistors handy, and the legs from the power resistors were big enough to fit in. I did have a problem finding the serial input because I had to bend the lead because I guess the contacts are a bit dodgy inside here. So that's something I'll have to work out when actually using this joystick with the computer. I'm not going to use it for any project. I don't have any ideas right now. I'm just going to put it with a serial monitor just to prove to you that it can be done. But for anybody who's interested, Arduino has a tutorial on this on their website, so you can check that out while you're watching my video. But in a sense, it's really just this for this controller. We'll take one last look at the controller before I start writing up some code or really stealing it from the Arduino well, not stealing, taking it from the Arduino website and using it and telling you it's their code, because it certainly isn't mine. So I'm going to use their code, and we're going to figure out which buttons are which. I may add, well, I'll tell you on the code side, but we can look at this PCB a bit more. It's, you know, by today's standards, really bad, dodgy soldering, hand soldered. But interestingly enough, they have put copper on for the name. It was made in 1988 by Spectra Video International Limited, Rev 2.0, so they've done one revision. I just find this tooth thing for the wires really interesting. I guess that's to give the guys hand soldering a bit easier job. I don't know if you can see that here, but I might have found another bodge. I'm just going to try to zoom in even though it's not focused, which is right here. The traces, there's copper on the trace for a very small bit. And I'm wondering if that's because the trace isn't broken, so they had to put copper on it, or if that just happened by accident through a bad process of solder, of, you know, not putting on the solder resist properly. I don't know. But the soldering really sucks. Hand soldering, really bad job. But it looks like this thing, we're going to have a pretty easy time hacking it, because, you know, it was pretty easy, aside from that one connection problem, to find the pinout. The pinout of this chip. This is a pretty standard chip. Really easy to use, it looks like. I haven't never used it before, and so this is the pinout here, so it looks like we're going to have a pretty easy time. Now what you probably want to do is just chop off the cable, maybe give yourself a few inches after in case you need the connector for something. I can't imagine what, but you might need the connector for something. So then what I did is I took a bunch of paper clips, I don't know if you can see that, and I stuck them in the controller. Okay, I stuck them in, these two pins aren't used. I stuck them in as per all the used pins on the diagram. And I taped the paper clips to sort of surround the connector like this. And then I alligator clipped on just to the paper clips the associated pins with some color coding. So a problem that may arise, I haven't actually tested this yet, which I probably should have, but whatever, is that I noticed that when I was doing this with the power resistor legs, which are a similar size to these paper clips, These are just, you know, regular old paper clips, nothing special. But the power resistors, sometimes you need to push or wiggle them around to actually get a connection. So I think I have a decent sideways force, a decent sideways force in these to actually make them have a connection, but I suspect the pins in there are rusty and definitely not gold-plated like they probably should be for repeated insertions, because even though this is the nicer controller, it's still made as cheap as they can get it. So that may pose a problem, is that these paper clips may not make the connection, and I may just have to suck it up and cut the wire. Clock pin to digital pin 7. So the clock to digital pin 7. Oh, not focused at all. Oh, well, you want to connect the clock to digital pin 7. You want to connect the latch to digital pin 8, and the data, or the serial input pin, to digital pin 9. And the latch pin, I mean this parallel serial control pin. So I've done exactly that, so now I'm going to go and program it, and I'll show you guys the finished program. Okay, so I have my Arduino powered up. It turns out there was already code on the internet for this, so I had to just change it to the pinout that I was using, which was different. So thank you to, let's see, who was it? Sebastian Tomzak for the code. It's on his website. I'll link that as well. It seems this paperclip thing I'm doing seems to work. Here's the joystick pulled apart. And you can see the transmit lights blinking on the Arduino. And here, I'm going to head over. This is the serial monitor. You can see it must be active low because I'm not pushing buttons and they're all 1. So I'm going to see if I can. I can't really get both of these in at once. See if you can see the 0 there when I press the button. It looks slightly different. This is the front trigger button. So this is this button here. Okay, when I push that button. And then when I push the last button, you notice it gets slightly shorter, and that's because that must be the last bit. We just have our latch, clock, and data pins. This controller data is what it's sending out, so it's just a byte. Sorry for the, terrible style of recording, but it works. So it just serial outputs, sets all the required inputs and outputs, and it digital writes the latch high and the clock high. And I believe clock is pretty standard on the rising edge, so I would assume that it's rising edge. I haven't looked it up in the datasheet. I should have. And latch is active low. So putting the latch low, I think, basically tells the 4021 that it should send the data, and keeping the latch high tells it to update the data inside. So it can't do both at once. Either it's updating the state of the button, or what it's doing is it's sending out data, but it can't do both at once. So then here it's going to set this void controller read. This is just a subroutine that he calls here in the main loop. So I probably should explain this first. But it just sets the controller data equals 0, just so there's nothing in it. Controller data is a byte. It'll set the latch low, which basically, and then the clock low. So this just starts oscillating the clock basically. He's turning it on and off. He sets the latch low because he's now ready to get data. This isn't my code, by the way. It's linked, like I said. Then he sets the latch high, so that tells it to then get the data. Sets the latch low, which tells it to send the data after 2 microseconds. Then he says the controller data in is the digital read of the data in, because basically what it's going to do is every time you pulse the clock pin, which is what this for loop is doing, pulsing the clock pin, every time he pulses it, it's going to give you the state of the next button. So then what he's doing is he gets the state of one button when he changes the clock, and then he shifts that over to make room for the next one in the byte until he's finally finished. And then once he's finished, he just says digital write it out, or sorry, serial print it out. So that's really all the meat of the code is doing, is this for loop right here, which is basically just saying pulse the clock pin on and off and digital read the output, and then shift it over to make room for the next one. So it's that simple, really. So I'm going to close it up and show you the final result. Just for reference, though, this paperclip thing appears to be working marvelously. No problems. Okay, so this is the byte that you're going to get out of the computer. Obviously, there's 8 bits in it, but what does each of these mean? So the state of each of these bits corresponds to one of the buttons on the joystick. So this one corresponds, the very first one corresponds to the top trigger, which is this top trigger. This is the bottom trigger right here. So I'm just going to refer to it as this is the bottom trigger. This is the top trigger. So I don't know which one is B or A. You'll have to figure that out on your own, but it should be pretty easy. And so keep in mind that when this is 0, it just goes away. So then you're only going to get 7. So you notice on the computer when I pressed that trigger, it went down to 7. Okay, so there was only 7 ones on the screen if you just press the top trigger. That's because it just turns to 0 and goes away because of the way the program's coded. But it's 0. Okay, and these are all active low, by the way. That's why I have them written as 1s. So if say this one is low, that would mean the start one, but we'll get there. So the second one is the bottom trigger here. So if this is low, it means the bottom trigger is being pressed, and the whole duration while it's being pressed is going to hold to 0, so not just on the edges. Then you have select, then start, then up, down, left, right. Okay, that's it.